Hi everyone, it's Mrs. Griffin with the Unit 6 Lesson 7 video where we're going to learn about how to use trigonometry to find sides of a right triangle. So please do this opening exercise on your own and we will go to the examples here. So for starters, we're going to look for the acute angle that we are using, and in this one it is the 30 degree. This is like our theta. This is where we're starting everything from. And then we will label our sides from there, just like we did on the finding angles. So across from our angle is the opposite. Across from the 90 is the hypotenuse. And next to both the angle and the 90 is the adjacent. And then just like the last lesson, we go to SOHCAHTOA and figure out which of the three ratios we'll be using based on which of the sides of the triangle we're looking for and which ones have values. So in number 1, we're being asked to find the length of BC. So if I put an X there, then I can see I have a value on the hypotenuse and I have a value on the adjacent, but my opposite side is blank. So I'm not going to be using either of the ratios that includes the letter O. That means I have to use cosine. So I'm going to write cosine first, and then normally we would write the angle as a variable, but here we know how many degrees it is. So I'm going to write cosine of 30. The cosine of 30 is equal to, and remember it's adjacent over hypotenuse, so that would be 6.64 over x. Now, unlike yesterday's lesson where we had to find the angle, so we had to separate cosine away, the letter x is not attached to cosine this time. So we're not trying to do an inverse. What we are trying to do is get that letter x all by itself. We're trying to isolate the variable. So the way that we do that is we cross multiply. So if we were to do this multiplication, we would do x times the cosine of 30. I'm going to write it just like that because it's not going to be part of the 30. The cosine of 30 is its own number and x is different from it. And then it would be 1 times 6.64. which is just 6.64. Now, whenever we have multiplication and we're trying to isolate the variable, we would divide, do the opposite, the inverse operation on both sides. And like I said, cosine of 30 is stuck together. That's all one number. And so we would keep it together because we're not trying to separate like yesterday. We're trying to get x alone, which now we've done. And then what we do is we type it exactly this way into the calculator, 6.64 divided by cosine 30, and we never use inverse. So remember, you always have to make sure you are in degree mode when you're doing trigonometry. If you're not, you have to go over and highlight it. And then we're going to type in 6.64 divided by cosine 30. And we are not going to put an inverse because we're not looking for the angle. And we're going to get 7.667, and to the nearest hundredth, that would be 7.67. All right, similarly, on number 2, we are looking for BC, so I'm going to put an X there. This time the angle is a 70, it's here. Across from it would be the X, so that's my opposite. Across from the 90 is the hypotenuse. And next to both of them would be the adjacent. And this one is blank this time. So we are not going to use any of the trigonometry ratios that involve A, or for the adjacent. So that means we can't use tangent and we can't use cosine. We have to use sine. So we're going to set that up. Sine of the angle, which is 70, is equal to opposite over hypotenuse. So x over 15.4. And then just like last time, we're going to cross multiply to get x by itself. When I do that, 1 times x is just x. And 0.4 times sine 70 is, like I said on the last one, going to be written just like that. Put the 15.4 in front of the sine 70 so that when you type it into your calculator, you don't forget to close the parentheses and mess everything up. That 15.4 does not multiply by the 70. It is a completely separate concept. So when we type this in, we're going to type it in as 15.4 times sine 70. And we're going to get 14.47 to the nearest hundredth. Now, if you had typed it in the other way and put the sine 70 first, that's okay as long as you remember to close the parentheses before you type in the 15.4. Otherwise, it will try to multiply the 15.4 by the 70 and change the angle of your triangle. We don't want to do that. Okay, moving on to number 3, we're finding x and y. So our angle is 53, y is the opposite of it, the 7 is the hypotenuse, and the x is the adjacent. And so we basically have to do 2 separate ratios using our SOHCAHTOA. So to find x, we'll do that one first. That would be the adjacent, and we'll use the hypotenuse, which is 7, so that's cosine. So we will write cosine for 53 equals the adjacent, which is x, over the hypotenuse, which is 7, and we will cross multiply. So we'll put cosine 53 over 1, and then we will get 7 times cosine 53, and type that straight in. 7 cosine 53. And if you forget to write the times, that's okay, because the calculator knows that stuck together means times. So to the nearest tenth, that would be 4.2. Okay, and then when we go to find y is the opposite. I'm going to use the 7 that they came up with because I know it wasn't rounded. And opposite and hypotenuse are together in sine. So sine of 53 is equal to y over 7. Notice how similar this is to what we did to find x. The only difference is that we are using sine instead of cosine. That is going to completely change what we do because sine is a different ratio. So when we do 7 times sine of 53, we will get 5.6. And what that does is essentially eliminates the need to do Pythag with a rounded number. Okay, same idea for number 4. The angle is a 30. Across from the 30 is your opposite. Across from the 90 is your hypotenuse. And between or next to the 90 and the 30 is your adjacent. Now, because this is a 30, 60, 90, you can still use your special right triangles and get your results from there, making the hypotenuse twice as big as the short side across from the 30, and then the medium side would have the radical 3 on it, and then you could put that into your calculator. But if you do your trigonometry, you'll get the same answers. So to find x, I'll show you the trig, opposite and adjacent, which is tangent. So tangent of 30 is equal to 9.2 over x. We'll cross multiply. Remember not to put the x in with the 30. And then since x is not alone here, we're going to divide by the tangent of 30 on both sides. So you do have to make sure x goes completely alone. That changes whether you're dividing or multiplying with your trig in the calculator. So 9.2 divided by tangent of 30 is 15.9. And if you had done 9.2 times the square root of 3 by doing your special right triangles, you would have gotten the same answer. All right, and then the hypotenuse, we'll use the special right triangles to find that. But you could also use trig. Okay. Number 5, now we don't have a special right triangle. So our 67 is our angle. Across from that's your opposite. Across from the 90 is your hypotenuse, and next to the angle and the 90 is your adjacent. I'll start with x, which is the adjacent, and then we also have a value for the opposite. So opposite and adjacent is tangent. So the angle is 67, the opposite is 21.6, and the adjacent is x, and I will cross multiply. When I do that, I get x times tangent of 67 equals 21.6. The x is not alone, so I do need to divide in this one by doing divided by tangent of 67 on both sides. And then to the nearest tenth, you're going to get 9.2 to the nearest tenth. And then to find z, we'll do opposite with hypotenuse, which is sine. So sine 67 equals 21.6 over z. And then just like the tangent one, we're going to cross multiply. And just like the tangent one, we have to divide to get the z by itself. So we're going to divide by sine 67 on both sides. And then to the nearest tenth, it'll be 23.5. Okay. Number 6, this is your angle 35. We're dealing with the opposite and the hypotenuse, so that's sine. So sine of 35 equals b over 16. We'll cross multiply. and get b equals 16 sine 35. And to the nearest hundredth, that would be 9.18. Okay, for number 7, the angle is 60. You can use a 30, 60, 90 if you would like for this. The hypotenuse is 8. That makes the short side 4, which makes j 4 radical 3. And you can round from there, making it 6.9, which would be 7 to the nearest kilometer. Okay, if you would like to do it a different way, you can also do trig for this one too. This would be the opposite in hypotenuse, so this would be sine of 60 equals j over 8, and 8 times sine 60 would get you 7 as well. So that is up to you. On to number 8. Our angle is 67. We're dealing with the opposite and the hypotenuse, so that is sine. So sine of the angle, which is 67, is equal to the opposite, which is 8, over the hypotenuse, which is c. We'll cross multiply. And then since c is not alone, it's not isolated, we're going to divide by the sine of 67 on both sides. And to the nearest meter, 8 divided by sine 67 would be about 9. Okay, for number 9, the 79 is here, so the opposite is here, which is blank. The hypotenuse is your 15, and k is your adjacent. That means you're dealing with cosine because you have adjacent and hypotenuse. So cosine of 79 equals the adjacent, which is k, over the hypotenuse, which is 15. Cross multiply. When you do that, the numbers are all on the right and the k is on the left, so k is isolated. And you're just going to type in 15 cosine 79. And you will get 2.86 to the nearest millimeter would be about 3. Okay, for number 10, this is 54. That would be the opposite. This would be the hypotenuse. This would be the adjacent. Opposite is blank. So we have to use adjacent and hypotenuse, which is cosine. So cosine of 54 equals d over 25. Cross multiply. And d is isolated, so we're just going to type it right in. 25 cosine of 54 is 14.69, so that would be 14.7 kilometers to the nearest tenth. For number 11, our 71 is our angle. Across from it is opposite, which is blank. Across from the 90 is the hypotenuse, which is e. And next to the 90 and the angle is the adjacent. So and this is another cosine because, again, it's adjacent and hypotenuse. So cosine of a 71 degree angle. The adjacent is 7 and the hypotenuse is e. Cross multiply. E is going to multiply by the cosine of 71. And 1 times 7 is 7. E is not isolated, so we do have to divide by the cosine of 71. And then we're going to type 7 divided by the cosine of 71 in your calculator. And you will get 21.500, which to the nearest millimeter would be 22. For number 12, 23 is our angle. Across from it is n, that's your opposite. Across from the 90 is your hypotenuse. Since it's opposite and hypotenuse, that's sine. So sine of 23 is equal to the opposite, which is n, over the hypotenuse, which is 38. Cross multiply. 1 times n is n. 38 times sine 23. N is alone, so you can type it right in. 38 sine 23 is 14.84-ish, which to the nearest centimeter would be about 15 centimeters. And finally, number 13, from a point 120 meters away from a building, Serena measures the angle between the ground and the top of the building to be 41. What's the height? So that would be the opposite side. And the 120 is next to the angle and the 90, making it the adjacent. So this is tangent. So tangent of 41 equals the height, which is y, the opposite side, over the adjacent, which is 120. And cross multiply. Y equals 120 times tangent of 41. And to the nearest meter, that would be 104.